So this is a useful model for thinking about many industries, kind of a cost-based approach. And this is an important point. This is a footnote. And a footnote that I don't think we've talked about yet this quarter is, we might as well do it now. Now's as good a time as any. Let's see, I see a market. And I see this point, and I see this point. Did we talk about this? We done this? Here's quantity and here's price. This is like embarrassing. This is like econ 0 or something. This is like econ 0. To be doing this in a graduate course is somewhat embarrassing, but I'll do it anyway. So this is quantity and price, and these are 2 points, okay? Maybe this is 2014 and 2015. All right? And I want to think about this in terms of supply and demand. Okay? Did we do this? I can't remember. No? All right. All right. So tell me what happened. Yeah. Yeah, well, but I want to actually emphasize a different part of it, which is important to realize. So, if I want to look at this picture, and let's think about this distance here, call this distance delta Q, and call this difference delta P. All right? Those are, think about those measured in percentage changes or log changes, right? So delta Q equals log of Q 2015 minus log of Q 2014, and delta P equals log of P 2015 minus log of Q 20 on P 2014. Okay, so that's my picture. And I want to think about this in terms of changes in supply and demand. That is, how much did demand or supply change between 2014 and 2015? How would we translate these observed changes in prices and quantity into what happened in terms of supply and demand? What can you say? Anybody got? Oh, you all took econ 0, right? Pretty much. Yeah. Okay. So assuming we have downward sloping demand, let's call it delta D is positive. Demand went up, right? Not just it moved to the right. Okay? Anybody be more precise than that? How much did the demand curve move? At a minimum, right? At a minimum. That is, whatever the demand curve did, whatever the demand curve was that went through that, right? Everybody agrees there was a demand curve that went through here. I don't see it, but I know it goes through that point. Everybody. That's the first thing to realize. The first thing to realize, and this is very different than the instrumental variables point. The point is, these points have to be in equilibrium, not just of supply and demand. They have to be an equilibrium for the demanders, and they have to be in equilibrium for the suppliers. So if I only, let's assume I forgot half of economics and only knew demand, that's all I knew, I would still know that there was some demand curve that went through this point, and in 2015, there was a different demand curve that went through that point. Everybody agrees with that, right? Without ever talking about supply. Regardless of monopoly, I don't care, whatever you want to say on the supply side, I know that there was a demand curve that went through that point because that's how it was in equilibrium. And there was a demand curve that went through that point because that's how that was in equilibrium. Correct? For sure, right? People forget that. They think, well, I got to know what happened to supply in order to, no. those points have to be consistent with whatever happened to demand. So immediately, whether I measure it as this shift here or I measure it as this shift here, that is, if I measure it by how much the demand curve shifted at the old price or how much the demand curve shifted at the new price, in either case, I'm going to say delta D has to be bigger than delta Q. Everybody agree with that? Okay. Now what about the supply side? If I have an upward sloping supply curve, then what must be true? Well, actually, for the same logic, I can prove delta S has to be less than delta Q. Right? For the same reason. Just draw the same picture. That is, I got this point and this point. I got some supply curves. Now, it's true, I don't even know which way supply shifted, but it could not have shifted out. Just draw this supply curve however you want. Make it steep. It couldn't shift out past here. The new demand supply curve, as long as it's upward sloping, has to come into the left of here, and the old one was here. Right? So what I know is delta D bigger than delta Q bigger than delta S. Now, how do I know that? Well, that's all because delta P is positive. If delta P is positive, then I know demand went up more than supply, and therefore they each split where the quantity shows up. If delta P was negative, then I know delta S is bigger than delta Q, bigger than delta D. All right, just goes the other way. All right? So that's an important thing to realize. There's actually a fair amount of information in that price quantity graph about what's happening in this marketplace. Okay? Another way to think about it is think about the following. On the demand side, I know delta Q is delta D plus the elasticity of demand times delta P. Everybody agrees with that? That is, the change in quantity I see consists of some shift in the demand curve and then some movement along the demand curve. Right? That's all there is. Similarly, delta Q equals delta S plus epsilon S delta P. So in fact, this implies delta D equals delta Q minus epsilon D delta P, and delta S equals delta Q minus epsilon S delta P. Okay? So we could back out. If we knew the elasticities, we wouldn't just have these inequalities. We could actually back out what the changes in supply and demand had to be if we knew the two elasticities. Okay? That's the basics of how you look at a market in terms of output, quantity and price changes. Okay? Now you can solve these two equations by setting them equal to each other. You get delta D equals delta D plus epsilon D delta P equals delta S plus epsilon S delta P. That implies delta P equals epsilon S minus epsilon, delta D minus delta S divided by epsilon S minus epsilon D. So that's our standard formula we get in economics that tells us the change in price depends on the increase in demand minus the increase in supply. So it's the growth in excess demand divided by basically the sum of the two elasticities, right? Because the epsilon D is negative. So it's basically the sum of the two elasticities. Any questions that people have about that? And then you can just plug that back in to get delta Q. You plug it into either demand equation to delta Q. Delta Q is then, anybody know what the formula for delta Q is? Actually turns out to be epsilon S delta D minus epsilon D delta S divided by epsilon S minus epsilon D. And now that looks like it's a difference. It's really an average, right? That is, the change in quantity is a weighted average of the change in demand and the change in supply. That's why it's always in the middle, right? Because these numerator weights, remember this minus epsilon D is a positive number. So these are just like 3 times this plus 1 times that divided by 4. Like 3/4 of one and 1/4 of the other. All right? You can just get that formula by just plugging this into here or plugging it into here. All right, everybody knows this stuff, right? Yes? Should. But it is kind of, do they teach this undergraduate econ? They don't? Why not? What? I got their diploma in the wrong place. Okay. All right, so that's the model. That's the model. That's basic supply and demand. We're not even going to use that whole thing, but that's a footnote to our lecture today. All right, any questions before we move